Hi, thank you for tuning in to my presentation. This is a report for EECE 492. My name is Harpinder Gurwal, and I'll be talking about electrical energy generation methods. Now, the 5 topics I will be discussing in this video are an overview of a turbine and generator, then 3 types of power: wind, hydroelectric, and nuclear, and the advantages and disadvantages of each. Now, this video is not a very super technical, in-depth review of each of these power technologies. It's rather a general overview and comparison to give you an idea of what they are like today in today's societies. So here is a turbine and generator. This is a turbine, this is a generator. The turbine powers this generator, and inside this generator a rotor revolves inside a stator, and a flow of current is created inside wire. And this turbine that powers the generator is normally powered by wind, or moving water, or steam, as I'll discuss later. So first I'd like to talk about wind power. As can be seen in this graph, in 2009, 35,000 units, or rather megawatts of energy were produced in the United States. As you can see from the slope of this graph, wind power has been seeing an exponential increase over the last 10 years and continues to grow in popularity. Here what you see is a wind turbine. It's connected to a body, and above which is a weather vane, which points the turbine into the direction of the wind, directly facing it, so it has maximum power output. Now inside of the body of the turbine is mechanical gears, which are connected to a generator. Since the blades of this turbine only spin at about roughly 20 RPM, the gears inside make the generator turn much quicker, up to about 2000 RPM. And here's a block diagram, and I just want to highlight in here that there's mechanical and electrical protection methods to ensure that the turbine does not spin out of control and is safe to operate. Now you may wonder, what is the worst case environmental impact of a wind turbine? And I'll just show you a quick video. Even though there's no gases emitted or anything like that, wind turbines are, for one, very loud, and 2, they create shadows. Now this may not seem like a big deal, but imagine living like this every day, and inside of rooms, which will be shown here, it looks like a light switch is being turned on and off almost every 5 seconds. As you can see, this would be a major disturbance to local homeowners. Now I'd like to discuss hydroelectric power. Now this is a photo of BC hydroelectric dam taken over 30 years ago. Just to give a general overview of how a hydroelectric power plant works, a dam is built, which is a major construction cost of the project, that creates a reservoir. Now this reservoir is narrowed down into this intake where the flow of water can be controlled by a control gate. Now when the gate is open, the water rushes through this section right here, which is called the penstock, and powers this turbine. The turbine spins and then in return powers the generator. The generator sends electricity along power lines to homes. Now this is a similar photo as was shown before of the turbine generator combination. As I just mentioned, the water flow goes into the turbine, making it propel and causing electricity to be generated. Now here's a photo of an experimental sensory fish. This was created to understand the effects of the turbine on fish. As fish travel downstream, they go into the penstock and pass the turbine and back into the water down below. Scientists wanted to explore the effects of, how harmful are these turbines towards fish, and studies were done to see which kind of methods and precautions could be taken to mitigate the harmful effects rather, on the fish. Once again, I'd like to show you a worst case environmental impact scenario. here I have a video of the Baldwin Hills Dam disaster. This is the dam, and as you can see here is a breach in the dam. This was caused by just pressure from the soil giving way, and as you can see in the video, the dam gets worse and worse. At this point, it's about 50. This breach is 50 feet across, and eventually it gives way, causing major flooding and making residents evacuate their homes. Great destruction, great destruction. And I would like to talk about nuclear power. So what you see here are cooling towers of a nuclear reactor plant. The steam that you see here is non-radioactive. Some people think that are mistaken and think that it is, but it is not. It's purely just water and non-harmful gases emitted from the cooling towers. So here is a breakdown of a cross-section of a nuclear power plant. Here's the reactor building where the reactor is located. I'll talk about more about this in just a second. Basically, we have a reactor that's creating heat that goes through here. I'll just show in the next slide here. So a reactor with uranium rods. These uranium rods, there's a nuclear fission process going on here where a nucleus, or rather, not nucleus, but a neutron splits an atom, which causes a chain reaction, which causes heat. Now this heat goes up through the boiler and produces steam. This steam powers a steam turbine, and the turbine powers a generator. Electricity is produced. Then there's steam condensed here. It's as well as some water added through here. The pump pumps back water to cool down the reactor as well. And so the amount of electricity can be controlled by the temperature of these rods. Now, nuclear power does have its drawbacks, and when things go wrong, they go very wrong. In Chernobyl, many years ago, there was an incident caused due to equipment failure, and recently in Fukushima, there was failure in the reactor due to the earthquake and tsunami. And so that is the worst case environmental effect. And I'll just show you how bad it actually is. Here's a video of the blast at Fukushima nuclear plant and where radiation was leaked from. After this blast and the entire event, radiation still exists today and will continue to, as is in the case of Chernobyl. And that's the explosion there. Back to these slides. So I'd just like to talk about the advantages and disadvantages of these three power generation methods. So firstly, we have wind power. Its advantages are it's a very clean, green source of energy, and it can be used in rural locations. However, its disadvantages are, if you look at the electricity generation in Canada in 2011, only amounts to about 1%, as well as the drawbacks of the shadows and noise that I was talking about. Hydroelectric power is very prominent in today's societies. In Canada, it's the largest source of energy or electricity generation. It is clean and renewable. It does produce very low emissions of greenhouse gases and produces no direct waste. However, natural disasters do happen, as our breach showed, and the construction costs of hydroelectric power are quite high. Finally, we have nuclear power. It generates up to 15% of electricity for Canada. It has a very, very high concentrated source of energy, and its waste is compact. However, the disasters that nuclear power produces, if there is one, are catastrophic, and that makes it potentially very dangerous. Additionally, the great challenge of nuclear power is dealing with the waste. Right now, there is no great solution to it, so as it stands, it still has some way to go before it's more prominent method of electricity generation in today's world. And so as a conclusion, today's societies rely heavily on electricity. To supply this demand, various methods of electricity generation are required, and in the future, each of these methods aims to become as efficient and sustainable as possible so that we can have a greener world. That concludes the end of this video. Thank you for tuning in. My name is Harpinder Garwal. Thanks again.